So hi students, so this is a continuation of our bar chart. So we have already started with our bar chart. So we are actually looking at this particular data set, which is the iris data set, and which contains the 3 species of iris plant. So these are the 3 species. So we have actually read from the CSV file, and we actually loaded into our data frame this iris data, and by using the info function we are able to see the range of number of entries, a number of columns, and also we are able to see the total number of non-null count, and we are able to see the data type as well. And of course, by using the head, we are able to see the first 5 entry from the data set. So we're going to have an idea how the data frame looks like. So if we want to know what are the species, the data under the species attribute or species column, so just by typing iris data square bracket species, so you're able to see all these various species. So now we're going to see how we can actually make a bar chart. So we're going to make the bar chart by using the sepal length CM, and we're going to actually use this sepal length CM versus the species, so that we can actually see each species what is the sepal length in centimeter. So we're going to write the following code. Let me try to enlarge this. So we're going to use the plot function, and we're going to use bar, and we're going to provide the x-axis, which should be our species, and we also need to provide our y-axis data, which is our sepal length CM. So these are both x and y input, and we're going to set the title. This is wrong spelling. So we're going to put the title as sepal CM versus species, and we're going to set the font size to 14, and we are also going to set the X label. So this will be the species, and we can also set the font size to be of the same. So we just copy this thing here. Let's copy this for the y-axis. So y-axis will be the sepal length CM. So font size, and we can use plot show, and here you have it. You're able to see all the sepal length in CM. This is the sepal length for all the 3 species. So from here we can actually see that it seems like for each species the sepal length is different. So this could be a very good factor for us to try to differentiate the species based on the proximate sepal length in centimeter. So similarly, we can also generate charts for the sepal width CM, petal length CM, and also the petal width CM. So it could be the same code. So let's try to copy this, paste it here. So this one is going to be species, and this will be sepal width. Then CM, this is going to be sepal width, and sepal width. Okay, so this is going to be sepal width cm. And we can also try to use the petal width and also the petal length. It's going to be more or less the same. So we're just going to copy the code. This is going to be the petal width. So we can change this petal width and petal width. So you can see for each species the petal width is different. And then we're going to also use for petal length. So maybe we can copy this whole code. And this is going to be petal length. So petal length cm, just need to make some minor changes only. And we have it. So from the previous chart that we have seen that in terms of the petal width and also length, it seems like the Iris virginica has the highest petal length, petal width. And how about sepal width? Sepal width, not sepal width. Did we do sepal length? Yeah, maybe we didn't do the sepal length, but we can actually try and see. No, I think we did sepal length, right? Yeah, sepal length. So Iris virginica seems to have the highest sepal length. So certain kind of attributes, right? Petal width and also petal length. And we can see that Iris setosa has the smallest petal length. Petal width also Iris setosa the smallest. Sepal I think Iris setosa is one of the biggest. And also sepal length Iris is the smallest. So all this nature, various nature that actually you do, you can actually try to use it to identify a particular type of species. So this is the power of visualization. So what if you want to plot these charts? Let me just, this one I can just remove. How about plotting these multiple bar plots of this Iris data set and on the same figure? So let's see how we can actually do that. So in order for us to show the multiple bar plots on Iris data sets on the same figure, we are going to actually use a map function. So why we want to actually use the map function is because this species is now going to be labeled as the x-axis, and now because we are having each species are having four attributes. So in order for us to actually plot these four attributes, we need to replace the representation of the species into a categorical format. So just try to follow along. So let's say we are going to create a dictionary object for my map. So we have the first one is for the Iris setosa. So we are going to assign this value as 0. Okay, then we are having Iris versicolor. Make sure the spellings are correct. This one we assign it to 2. These values of 0 and 2, and after this what we're going to set Iris, this is virginica. These values 0, 2 and 4 are the values on the x-axis. We want to actually plot it on the x-axis. So just try to follow along. Why we actually choosing 0, 2 and 4, we will actually see shortly. And what we're going to do is we are going to have this as maybe mapped series. We're just going to take the iris data, and we are actually taking the attributes of species, and we are going to use the replace function, and we're going to replace it with my map. So what this will do is it will take the iris data column species, which has 3 species, and it will replace all these 3 species. These are all the names of the species, right? It will replace with my map, which means it will replace with the value 0, 2 and 4, but it won't do that on the original data set. It will replace and it will be stored in this mapped series, which means map series will only have, so if we look at map series, we'll only have the representation now replaced, right, from 0 to 149, which means the length is the same. But now we replace the species with these values 0, 2 and 4 which will be the x-axis value. So that's what we are actually doing. So now when we want to plot, just to show you a simple example on this values of x-axis of 0, 2 and 4, we use this function known as xticks. So xticks means you're actually setting the x-axis. Let me show if there's an image. This one is known as the ticks. This is the x-axis ticks. So you see the small tick is here. So this is the x ticks. So when you're using this function xticks, you're able to set the location. So in this case, let's say the location we want to be on 0, 2 and 4, and we want to name each tick. We want to label each tick as Satosa, the first one, first tick. The second tick we want to name it as versicolor, and the third tick we want it to be named as Virginica. So let's see if we do the plot show. You see that now you have the Satosa, which is at 0 tick, and this is at x2, axis 2. This is 0, this is 1, this is 2, this is 3, this is 4. So at 0 we want it to be Satosa. At 2 we want the x tick to be at the position x axis 2, value 2, and we want the versicolor. And at x axis value 4 we want another x tick here, and we want to name it as Virginica. So this is just to show you why we're actually doing that. But for each one of these species we are going to have 4 bar plots. We're going to have 4 bar plots here, right? That's what we're going to do. So let's see how we can actually do that. So we're going to have the plot bar. Now remember, when you're using the plot bar function, you need to provide the x-axis value, right? So currently, okay, let me just minimize this a little bit. So for the first one, actually we'll have to plot four bars here, right? We have to do 4 bars. So what we actually want to do is we need to specify the x values here, and then we'll actually give the y-axis value, which is the iris data, and we are taking it from the, let's say we're doing the sepal length in cm. So we can actually, I'll just leave this x temporarily as x for now. Let me just enlarge this. So this is will be our x axis value or category. But remember that now we're going to have 4 bar plots, so there's something that we have to deal with this. So we will say that shortly. So we'll put the y-axis values because that's easier for you to understand. We can also set the color, and we can use the color code. We don't have to write the color in full. We can use, like for example, the color code, which is B is for, this is blue, if I'm not mistaken. B is for blue. So B is for blue, and we can actually set the width of the bar plot. So let's say that we set the width as 0.25. We can also set the label. We can actually set the label because we're going to have 4, right? So let us actually set the label. So this one will set the label as same, sepal length. Okay, so we'll do that. So now we need to do this for all 4 sepal width, petal length, and petal width, right? So just going to paste it, paste it, paste it. So this one we need to actually change to, this will be sepal width, this will be petal length, and this will be this petal, and this will be petal width. So now we have all 4: sepal length, sepal width, petal length, petal width. So the first one is blue, the second one we can actually have green, which is G, red, and we can have black, which is K, all with the width of 0.25. and of course we need to change the label accordingly. This will be sepal width, this will be petal length, and this will be petal width. Okay, so we have included all that. Of course, as part of the chart, we can actually include the legend. Automatically, it will show all these 4 labels. Now, let us actually try to handle this x-axis value. So here, what we are actually going to do, if we look at here, this is our x-axis value, which is 0, 2, and 4. So how can we actually plot? So we want all the 4 bars to be here, right? So what we're going to do is we're going to use this map value. So we can use the first one, which is the mapped series, not series, the map. Sorry, I think map series won't make the proper, it's supposed to be mapped species. Yeah, this will make more sense. Map species. So map species. So the map species, what we're actually trying to do is for the Setosa, which is on the x-axis here, right? For the Setosa, the map series value is actually 0, right? This is where the x-axis is. But we want all the 4 plots to be here. And maybe I don't want my Setosa to, the label to be too close here. So what I'm going to do is I'm going to use a negative offset, which is negative 0.25. Why do I use this 0.25? Is because the width that we are using is 0.25. And we are going to divide this by 2. Why we are dividing by 2? is because we need to set the tick, the X tick for this value. So remember that the width is 0.25, which is the total width. So let's say, assuming that this is, I'm just using this chart as an example, assuming that this whole x-axis here is the width of the bar. So that means, which is from here to here, it will be 0.25. When we divide 2, you get the center point, right? So that is why we are dividing by 2, to get the center point for, so this will be the x value. This will be the x value. So at x, map species minus offset minus 2.5 divided by 2, which means from 0 you are going to minus 0.25 and you're going to take half of it. So now this thing will be moved a little bit. So the same thing that we are going to, let me see if I can actually show this, whether it's able to plot or not. Let's see. Yeah. So you can see here that now Setosa, this x tick here, this is 0, right? This is what we have set, 0, right? 0, the x value. So when minus 2.5, which means from here, this is minus 2.5. And divide by 2 means you get this center point. So what we're doing is we are setting the center point. If you don't divide by 2, what happens? That 0.25 becomes your center point. So if you just do something like this, you will see that there's a gap here. So which means 0.25 is your center point. But we want all these others to be close together, so that's why we are dividing by 2. I hope you are able to understand this point. So this is 0, 0.25 is here, this is 0.25, divided by 2 is the center. So when you take the center point, the whole total width will become 0.25. Okay, so we want to do it for the rest one by one also. So this one, how about this? This is for map series. So this one, what shall we do? So map series, let's say we are talking about Setosa, and automatically applies for all the species as well. So you're just taking this offset. So map series is what? This is 0. You want to plus 2.5, which is somewhere here. This is plus 2.5. Divide by 2, which means this is your center, right? This is center of your bar plot. So this will be plus 0.25 divided by 2. So when you do this, there. If you don't divide by 2, what will happen is your center point becomes here. This will be your center point and the bar will be plotted here, this side, this range. So there will be a gap. So it looks like this, there. You see? So the center point is 2.5. So from 0 to 2.5, this is the center point. So then, there's a gap in the plot. So we don't want that. So that's why we are dividing by 2. So I hope this is clear. So how about the next one? So the next one, let me just copy this, put it here. So the next one from here, it is plus 0.25 plus with 0.25 divided by 2. So this one, we're just going to put 0.25 plus, sorry, plus 0.25 divided by 2, right? So if you do that, there you get sepal width. And the last one, the map series. So this one from here 0.25, 0.25 plus 0.25 divided by 2, so you get the center point. So 0.25, 0.25 becomes 0.5, so straight away we can just put 0.5 here, and there you have it. So now you're able to actually plot all these four. So this is how you plot multiple bar plots. Thank you. So I stop recording here.